This is a detailed answer key for the 3133 assessment. First question, always important. Let's make sure we're reading the directions. What are they asking for? What is it? What do we need to do in order to answer that question? So it says determine whether a relation is a function. So a function means for every input there is one unique output. So we're looking at the x values. We're going to look at the x value, the x value, the x value, x, 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 and x. And since none of these x values repeat, we are not able to, well, since we make that assumption that it is a function, because when you input 0, you're going to get 4. So there's no other instance where we input a 0 where we don't get 4. So we would make the understanding that this is a function. In question number 2, we're going to look at every x value. We look at the x values, and we notice that when we input 1, we got -3, and then when we inputted 1, we got -2. So we didn't get a unique output for one input. We got two outputs. When you entered 1, you got -3, and when you entered 1, you got -2. So that is not a function. So it has nothing to do with slope. It has nothing to do with any other thing other than your inputs and your outputs. So we're just going to look at the inputs. We're going to look to see if the input repeats. If it repeats, does it produce the same output? So it's not that it can't repeat. It just can't produce two different outputs. State the domain and range. We want to know what the domain refers to the x values. So we want to know all of the x values that are solutions to this line. Since those are arrows and go on forever, our x value, our domain, is going to be all real numbers. We go from -infinity to +infinity. The way we state that when we're talking about domain, we say all real numbers. You can't do -infinity to +infinity. That's not the proper way. The range, and you will see the range, although it looks like it doesn't go up to +infinity and down to -infinity, it sort of looks like it sits in between this range. That's not true. It also are all real numbers. And we put it in solution sets, not parentheses. Parentheses are coordinates. Now here, our domain, our x values, our domain again are all real numbers. But this time our range has a limit. It does not go above 6. So we say y is less than or equal to 6. We have to use y for range, and this is a solution, so that is the 0.16. So 6 is a solution, and then every number less than 6. So y is less than or equal to 6 is how we would state that. List the intercept. So when we talk about the x-intercepts, we're talking about where this graph crosses the x-axis. It crosses the x-axis at these three locations. It touches the x-axis at those 3 points. And again, we don't use, if you're going to use parentheses, use coordinates. So you would say -2, 0, you'd say 0, 0, and you'd say 2, 0. You could also list it as -2, 0, and 2, but those need to be in solution sets. You can't use parentheses. You can't write this because that looks like a coordinate. That would be incorrect. And then the y-intercept is where it crosses the y-axis. So where does this graph cross the y-axis? Well, it crosses it right there. So there's one location. There's going to be one y-intercept, and we can either put it in a solution set or we can write its coordinate. I don't care which one, just write it using the proper notation. So x-intercepts again, let's use a little one. So -3, that could be a third, -1/3, and 1/3, it could be a half. I'm okay. It says approximate. So give me your best. So I'm going to say -3, -1/3, 1/3, and 3. My y-intercepts, and notice I'm looking at the increments. The x-axis is on increments of 1. The y-axis is in increments of 2. So if you didn't notice that, notice that that is not a half, that is actually 1. So my y-intercept would be +1. That's the only location it crosses the y-axis. Approximate when the function is positive and negative. When we talk about positive and negative, we're talking about outputs. When is the output positive? When is the output negative? And we want to know by providing the inputs what x values produce positive outputs, what x values produce negative. So I would, again, I would list, I would make sure that I tell you which one I'm solving for or providing you information. So when are my outputs, my y values positive? Well, my y values are positive here. That's a horrible line. Are here. No, it's not going to do it, are you? Here are my positive y's. Now, at this point here, it is neither positive nor negative. Your y value is 0, so your y value is not positive. When is my y value positive? So starting, my x values are going to be greater than -2. That's when my output. So when x is -2, it's it's neutral. But once I start going to the right of -2 or getting greater than -2, my outputs are above my x-axis. So I would write positive, and I could write it like this. X is greater than -2. When is it negative? When is it below the x-axis? When it's below the x-axis, my x values, my inputs, I'm asking what are my inputs when my outputs are negative? My inputs deal with x's, so when x is less than -2. When x is equal to -2, it is neutral. It is neither positive nor negative y value, outputs. So we have to be you got to understand what you're talking about. And you have to understand what the question is asking. So when is it positive? It's positive in this section here. So how do I state those x values? It is positive between the points -4 and 2. So I would write -4 is less than x, which is less than 2. I don't have equal signs on my inequalities because at -4 it's neutral. And I don't write two statements, and I don't write it, I would write it in numerical order, -4 and 2. The smaller is always going to be to the left. When is it negative? This is the one place where I'm going to give you a little leeway. So when is it negative? Well, it's going to be negative here, and it's going to be negative here. So if you want to write when x is less than -4 or x is greater than 2, I'm okay if you said or. I'm okay if you wrote and. I didn't mind either one, but I was not going to take this. This is not what you can do because that is not a proper statement. It's not in numerical order, and there's no number that is greater than 2 and less than -4. That's why I like or in this better than and I'm definitely not going to take that compound inequality. You cannot write a compound inequality for that. Approximate when the function is increasing and decreasing. So when we pick a point going left to right, when are my y values, my outputs increasing? So it is increasing in there. So when does it start increasing? I'm going to label what my answer is. So I'm going to write the word increasing. I'm not just going to put anything. I'm not going to just leave it blank. And we want to know what are our inputs. So when x is greater than 3. And we're not going to do equal to in that either. So when the values, my x values are greater than 3, my points, my outputs are increasing. When is it decreasing left and to right? Now this looks like it's going in this direction, but it's not, because remember, we are looking at it left to right. So left to right, it is going down. That is when it's decreasing. So decreasing, how do we do those values? Now you're going to say x is less than 3. That's the hard part, because when we look at x is less than 3, we go right to left. But remember, I'm looking at it left to right. How do I do that? This is the most complex. That's the most challenging problem right there. And this is kind of hard too. So let's go over increasing. When is it increasing left to right? So when we go left to right, when is it increasing? Well, it's increasing left to right here, and it's increasing left to right in that section. So how do I say those two uniquely? So at -2, when x is less than -2, or when x is greater than 0. So at 0, it starts increasing. So when is it decreasing? Decreasing is going to be between these two sections. That's when it's decreasing. It's decreasing from there. So at -2, between -2 and 0. So I write -2 is less than x, which is less than 0. And those are my solutions. I can write them in solution sets. Now I don't include, so those are again not, they're just less than signs. And I want values that are greater than -2 all the way up to 0. What is the end behavior? So when we talk about end behaviors, there are two end behaviors. There is this end behavior and there is this end behavior. There were way too many people who just gave me one end behavior. So one of the end behaviors, as x moves to -infinity, as x goes to the left, as we go to the left, what does the graph do? Y goes up, and up is positive infinity. That's one of the end behaviors. That's the blue end behavior, the left one. So this represents the left end behavior. If we look at the right end behavior, as x goes to the right, aka positive infinity, what does the graph do? The graph goes down. If we want to write down, that is negative infinity. So that would represent the right side end behavior. So I need two answers there. Do the coordinates represent a linear or nonlinear function? This is derived by the slope. Linear has a constant slope, and we derive slope from one point to the other. So my x's are going to be +4, and my y's are going to be plus, what's that, 18 from that point to that point. And then if we go to this other one, Let's go from this point to this point. That's plus 2, and that is plus 9. Now that doesn't tell me, it's not the gaps between them, it is the slope. Slope is rise over run. That's my y's over my x's. My difference of y's over my difference of x's. So I have my y's in the bottom, my x's in the top. So I have 18 over 4, which reduces to 9 over 2. And then I have 9 over 2, which simplifies to 9 over 2. So they have the same slope. Since they have the same slope, this is going to be a linear function. Let's look at the next one. So we're going to start with the x's. That's plus 2. And then the y's are plus 26. And we go to the next point. That's going to be plus 2. And that's going to be plus 98. So if we do the slope, which is rise over run, y's over x's, we have 26 over 2, which simplifies to 13. And then we have 98 over 2, which simplifies to 49. So these do not have the same slope. So this is nonlinear, since it doesn't have a constant rate of change, a constant slope. Last 3 questions. An 18,000-gallon swimming pool is draining at a rate of 30 gallons per minute. Okay, so 30 gallons times minutes will tell me how much water is drained. Okay, so we can do it in that way. We could have also written 18,000 minus 30 m. I'm okay with that. This represents the amount of gallons in the pool. This represents the amount of gallons per minute that is draining from the pool. And this represents the number of gallons left. Either way you want. M is the number of minutes. 30 is the rate of draining. And 18,000 is our starting amount. Is the remaining gallons a function of time? Yes, it's a function of minutes. List the domain of the function. So when you say list the domain, it doesn't say state the domain, state what the domain is. It says list the domain of the function. What are the values? If we had to graph this, what are the values? Well, we're going to start at 1800. Right, that's how much water, and then time. So this is water remaining. This is minutes. That's at 0 minutes. If we plug in 0 here, that's going to leave us with 18,000 gallons. Now after 1 minute, you have 30 minutes. So what's that? That's going to be 0. So one solution is 0, 18,000. Then it's going to be 1, 17,970. And then 2, 3, 4, 5, 6, blah, 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 blah. So the domain, what are my x values? Remember the points that we just talked about. The solutions are 0, 18,000, 1, 17,970. And then we're going to see, and it's going to continue to go. And when is it 0? So I can do a little quick math here. When is the remaining gallon 0? You can do 18,000 minus 30m. So we can subtract. We're going to solve for this. We're going to solve for m. We get negative 18,000 equals negative 30m. We're going to divide both sides by negative 30. So 18,000 divided by 30, it's going to give me 600. So positive 600. So 600, after 600 minutes, there's going to be 0 gallons left remaining in the pool. So what are my domain? What is my domain? What are all my x values? My x values would go from 0 to 600. So list the domain. You would say 0 is less than or equal to m, which is less than or equal to 600. And we would use equal signs because we can be at 0 and we can be at times 600. And we do the variable m or t or whatever you use for your variable here. And then, is the domain of the function continuous or discrete? It is continuous because OUS, because we can have partial minutes. It is draining and it is continuous from the time you start your watch to the 600th minute. It is not discrete. Discrete means it's points, right? Meaning minute 1, minute 2. It doesn't drain 30 gallons at minute 1. It continuously drains 30 gallons throughout that minute. And that's it. So that's a detailed description for you to use to make sure that you are proficient on the test that you took.